Welcome to this e-lecture, which is about correlation and regression and the difference between correlation and regression analysis. So, first of all, what is the difference between regression analysis and correlation analysis? The most important difference is that when you do a regression analysis, there's an asymmetrical relationship between the two variables. It's asymmetric in the sense that in a regression analysis you analyze how the average on the dependent variable, the effect, changes when one or more of the independent variables, the causes, increases in value. So you have a dependent-independent variable relationship. And the purpose need not to be causal analysis in the sense of cause-effect, but it may also be descriptive or prediction that you, for example, predict what is your level of trust or happiness given, which is then the dependent variable, given some values on certain independent variables such as sex, income, age, and so forth. Whereas with the correlation analysis, there's a symmetrical relationship between the two variables. You do not differ between the dependent and the independent variable, and it's a more general measure of the covariation between variables. So if we look at more closely on the regression analysis, we are really working with, and also with a correlation analysis, we're working with a linear relationship. So we look at the linear relationship between two variables. If we didn't divide between dependent and independent variable, this could be as well, we could say that this is the correlation between working hours per week and weekly wage in Norwegian kroner. But if we look at think of this as a independent and dependent variable relationship, we say that okay, if you work, the more you work, the more you earn. So your weekly wages is depending, this is the dependent variable, is depending on the independent variable, which is working hours per week. So weekly wages is defined by number of working hours per week. So if you work 5 hours per week, you earn 500, and if you work 10 hours per week, you earn 1,000. And if you work 15 hours, you earn 1,500 Norwegian kroner per week. And if you don't work at all, it's 0. But we can also be in the situation that on average everyone has 500 kroner if they don't work at all. So people that don't work at all, they will earn 500. And there's an increase in your weekly wage as the more you work. So if you work 20 hours, you earn 2,500 kroner per week. And this function between a dependent and independent and dependent variable can be expressed in this kind of equation, where the y is the dependent variable and a is the constant, and that's the value on the dependent variable y when the independent variable x equals 0. So if you put in a 0 for the x, so b times 0 is 0, so then this whole part falls away. So then you just then you're left with the a, and that's the dependent variable. That's the value on y when x is 0, as we can see from the graph. And the b is the regression coefficient. That is a change in the dependent variable when independent variable x increases with 1 value unit. So it shows you how much the dependent variable increases when the independent variable increases with 1 value unit. And our goal is really to estimate a linear trend in the relationship between variables, and that is get a line that summarizes the data as best as possible. And in this figure, we have the publics or the public share of health expenditure. So it's the how much the state uses on health, the total health expenditures, and then it's life expectancy on the y-axis. So as we can see, that there's a positive slope, or a positive or an increase. So it really shows that the more and all these dots are countries, and so there are different values there are different values on life expectancy, and how much the great share the state uses on health. And what we can see is that so the larger the state's share of the total health expenditures are, the longer are or the highest the life expectancy in these countries. And what we get is that we get that the dependent variable, or the constant, is 58.4 years. That means that in a country where the state's share of the total health expenditures are 0, x is 0, so this falls away, then the life expectancy is estimated to be 58.4 years. And as you can see, there is no countries that uses 0 where the state's total share of the health expenditures are 0. So that's just a technical interpretation. But for each percentage point, the more the state, the larger the state's share of the total health expenditures are, life expectancy increases by 0.2 years. So that's what this equation tells us. Okay, that was the short introduction to correlation and regression, and the e-lecture about correlation and regression. Thank you so much.